So if you've ever worked in tech or in development or, even just managed a home server for fun, you have absolutely heard the words that can just completely ruin your entire week.
Let me guess.
It works on my machine.
The classic, yes.
It's the ultimate paradox, isn't it?
Yeah.
You've tested your code. It runs perfectly on your laptop.
Flawlessly.
Then you move it. Test the environment, or worse, production, and boom, the application crashes.
And it's always for some tiny, infuriating reason. A Python library is missing. A firewall port is blocked.
Or the OS has a dependency that's 3 years out of date. It's that environment mismatch, that configuration drift. It's a nightmare.
It is.
Today, we're deep diving into the disciplines that were designed specifically to kill that chaos, to enforce system integrity.
Right.
We're talking about configuration management, or CM, and its siblings, software configuration management, SCM.
Right.
Our mission here is to understand how experts manage this complexity at scale and hopefully give you the key insights into the trade-offs they're facing every day.
And it's so crucial to start with the core idea. CM is, at its heart, the systematic response to that drift you mentioned.
Okay.
It's the practice of handling every single change systematically. The goal is to maintain integrity and provide a totally accurate, non-negotiable historical record of system states.
And SCM brings in another key piece of that.
It introduces the absolute foundation of the entire approach, which is the baseline.
It's a baseline.
The baseline is the anchor for your entire system. Think of it as the agreed-to perfect description of every single attribute, the code, the dependencies, the OS version, all frozen at a specific stable point in time. Everything that happens after that is measured against that baseline.
That makes a lot of sense. So the baseline isn't just the final code. It's the entire ecosystem.
The whole thing, yeah.
The OS, the libraries, the config files, network settings, all frozen. So you can just replicate perfection.
Exactly.
But let's remember the dark ages this was all born out of.
Yeah.
We looked at sources describing the time before CM was standardized.
Oh, yeah.
And imagining manually configuring a massive server room. Our sources called it, I think the quote was, a very hectic job.
Hectic is an understatement. It was a full-blown management crisis. The pain points were just excruciating.
Like what?
Well, after any manual update, if something broke, trying to find a stable version to roll back to was described as very difficult.
So there was no easy undo button.
No, there's no guaranteed, consistent path back to stability. You were just guessing.
And the cost of that environment mismatch we talked about must have been astronomical.
It was. You'd have developers using some bleeding-edge database in dev, while production was stuck on a version from years ago. You just couldn't trust the environment, which means you couldn't trust the code.
Right.
And that inability to trust the environment is precisely why CM isn't optional anymore. It's absolutely fundamental to DevOps.
So it's not just a component of DevOps.
No, our sources are emphatic. It's essential. It enables organizational agility because it automates all of those tedious, error-prone tasks.
And that automation, that's where infrastructure as code comes in, right? IAC.
That's the one. It flows directly from this. Instead of, clicking through menus or running one-off scripts on different servers, you define and provision your entire environment, dev, test, prod centrally. You do it by writing configuration files that act as code for your infrastructure.
Which means you can replicate the desired state anywhere.
Instantly. And repeatedly.
So configuration management at the end of the day is about making sure the product's performance and its attributes align perfectly with the design and then preserving that consistency for its entire life.
You're transforming complex infrastructure into a set of predictable files. That's the magic.
Okay.
And to get that stability, SCM needs some real process rigor.
Yeah.
Now, there's a comprehensive life cycle that can have, a dozen steps or more. But what really matters is that these processes protect the sanctity of that baseline.
Right. So instead of listing out a formal 12-step process, which is maybe overkill for us.
Yeah, let's not.
Let's focus on the 4 basic control functions that our sources say are non-negotiable for SCM to actually work.
Good idea. They're like the scaffolding that holds the whole thing together. First, you have identification.
So naming things.
Pretty much. Identifying and naming every single configuration item that belongs in that baseline. Second is control. This governs the release process and manages every change made against that baseline.
So nothing gets changed without a process.
Nothing. Third is status accounting. It's simply recording and reporting the status of every component and every change request. It gives you a perfect, immutable audit trail.
Okay, so identification, control, status accounting. What's the last one?
And finally, auditing and reviewing. This is where you validate that the final system is complete and, just as importantly, you verify that the SCM procedures were actually followed.
Okay, so let's bring this back down to earth. For someone listening, why should you care about all this rigor? I mean, beyond just reducing errors.
It's about business velocity.
And so,
Well, let's take productivity. It isn't just about fewer bugs. It's about freeing up your developers' time.
because they're not debugging the platform.
Exactly. If the environment is guaranteed to match, developers stop wasting hours on platform differences and can focus purely on building features. That speeds everything up, which, translates directly to cost savings.
And that speed is also supported by better collaboration, right?
Right. SCM's control methods can easily handle lots of people making updates without conflicts. But here's something that's often overlooked. It's how SCM accommodates external changes.
External changes, you mean like new requirements?
That and more. Our sources show how changes in requirements, or the team itself, or even government policy. All of these can affect the underlying code, the documents, the tests. SCM provides the framework to absorb and track those shifts systematically. It stops that policy drift from breaking your system.
That's a powerful point. So if a new government policy changes logging requirements,
Yeah.
CM makes sure that policy is updated consistently across all 100 of your servers at the same time.
Precisely. And that connects directly to compliance and stability. CM enables continuous compliance. It helps you catch deviations in real time. And this is the crucial part, it corrects the system back to the desired state.
The self-healing part.
That's the magic of self-healing IAC. It prevents unauthorized changes and actively restores the configuration when it finds something's gone wrong.
It's clear CM is necessary, but okay, how does this actually work under the hood? We're talking policy, but how does it execute? It seems like there are two basic sort of competing philosophies in the tool space. Push and pull.
This is the big architectural trade-off. It's really all about who initiates the action.
Okay.
With a push configuration, you have a centralized server. It holds all the configuration definitions, and it actively initiates and pushes those configurations out to the target nodes, the machines being managed.
So the server is the command center.
The authoritative command center, yes.
Yeah.
And then you have the opposite approach.
Pull configuration.
Yes. In the pull model, the nodes themselves start the action. They periodically poll or check in with the central server to see if there are any updates or if they've drifted from that desired state.
And if they have.
If they find a new configuration catalog that specifies a change, they just dynamically update themselves.
When we look at the tools out there, we see this split with major players like Ansible, Puppet, Chef, SaltStack.
A lot of them, yeah.
Let's dive into two big examples that really represent these different philosophies, starting with Ansible.
Good choice.
Ansible is almost always described as the simple, powerful, open-source automation tool. And it's the purest example of a push-based system.
And its biggest differentiator, the thing everyone talks about, is that it is agentless.
Agentless. Why is that such a big deal?
It's a huge benefit for speed and simplicity. You don't need any special agent or client software running on the remote hosts you want to manage.
So how does it talk to them?
It communicates using simple native methods, usually SSH keys or, standard passwords.
So it's versatile.
Incredibly versatile. It handles the full life cycle, from provisioning the raw server resources all the way to ongoing configuration management. It uses these things called playbooks to act as the orchestrator for the entire stack.
Okay, let's clarify that. When we say provisioning,
We mean automating the creation of resources, spinning up a server on Azure, setting up new users, new file structures, that kind of thing.
and what exactly is a playbook?
But the playbook is your instruction set. It's the marching orders for the whole infrastructure, written in this human-readable format called YAML. It just describes the desired state.
And when you run it,
When you execute that playbook, Ansible starts provisioning, configuring, and most importantly, orchestrating the application stack.
orchestrating, like a conductor.
It's the perfect analogy. It's more than just running a script. It's coordinating the whole band. The playbook makes sure the database is configured before the backend service starts, and that the backend starts before the front-end load balancer is updated. It makes sure all those interconnected tasks happen in the proper cohesive order.
Okay, so that's Ansible. Simple, agentless, push-based. Now let's shift to the other side of the debate. Puppet.
Right.
Puppet is a classic master-slave architecture, and it's the poster child for the pull-based model, written mostly in Ruby.
Puppet is really designed for control and rigor, especially in very large environments. And because it's a master-slave setup, it requires a Puppet agent to be running on every managed node. That agent is what implements the pull model.
And that cycle is very specific, right?
It's highly regulated. It starts when the agent sends facts about its current state to the puppet master.
Facts.
Yeah, just normalized data, what OS it's running, how much memory it has, things like that. The master uses those facts to compile a very precise catalog.
And the catalog is.
The detailed specification of how that node needs to be configured to reach the desired state.
So it's basically the difference between the node's current state and the ideal baseline.
Precisely. The node then executes that catalog, makes all the necessary changes, and then sends a final report back to the master confirming that the configuration is complete.
And I'm guessing that's all secure.
Oh yeah, the whole communication process is secured using SSL encryption.
That constant check-in and reporting sounds incredibly robust, but it brings us to the core trade-off, doesn't it?
It does.
Ansible is praised for its agentless simplicity. Puppet has the overhead of an agent running on every single machine. Why would a huge organization choose Puppet, given that extra complexity?
That is the key question for any practitioner. And while the agent definitely adds overhead, it provides a massive benefit, a superior audit trail, and really rigorous self-healing.
How so?
Because that agent is constantly sending facts and reporting its execution status back to the master, Puppet gives you an automatic centralized history of every config change and every compliance deviation.
So, always watching.
Always. If you're managing 100 servers, you write one piece of code, and Puppet guarantees that all 100 servers not only get that configuration, but constantly verify and report that they are still compliant.
And that's critical for certain industries.
Essential for compliance-heavy environments. It's why you see these massive organizations, Spotify, Google, even the U.S. Air Force adopting it.
Yeah.
It provides consistency and drastically reduces downtime from misconfiguration. It's a huge disaster recovery benefit.
So, to summarize the difference then, Ansible gives you simplicity, agentless operation, and great orchestration for deployments and updates.
Right.
Whereas Puppet offers this deep, continuous compliance enforcement and superior reporting, but at the cost of requiring an agent.
It's a trade-off between simplicity and systemic control.
So what does this all mean for the bigger picture? I mean, it seems like configuration management fundamentally shifts how we manage this sprawling infrastructure. It takes it from chaotic manual labor, which was, hectic and unreliable, to scalable, repeatable, automated code.
And that really is the genius of CM. It ensures continuous compliance and just drastically increases the speed at which organizations can safely operate. What's truly fascinating to me is how these practices connect a high-level business need, like agility, with very low-level management.
What do you mean?
Well, think about it. A compliance officer defines a policy. It requires specific user permissions on a certain port. CM translates that high-level rule almost instantly into a Puppet catalog or an Ansible playbook that manages individual users and permissions on port 8080 across every single server with no manual intervention.
It closes the gap between the business requirement and the actual execution.
It closes that gap completely.
But the whole system, as you said, depends on defining that ideal desired state. If CM makes rollback easy and environment matching consistent, we've solved the works on my machine problem. But what happens when the requirements themselves become the source of the chaos?
That's the next frontier.
Right. These systems are designed to revert to an ideal state, but what if that desired state has to constantly evolve because of rapid policy-driven changes? A new security requirement every month, a constant schedule shift. The system is just chasing a moving target. What does it even mean to strive for a perfect configuration when the definition of perfect is always shifting beneath your feet? Something to think about, I guess, as you manage infrastructure in this age of constant change.